So we're here at Future Facade, here with Florian. So if you just want to introduce yourself, Florian, and where you're from.
Yeah, hello. I'm Florian. I'm a senior scientist at the University of Technology in Vienna and at KAUST in Saudi Arabia. And I'm mainly working on architectural geometry, freeform facades, and computational design.
Cool. And what do we have here?
Yeah, this is our latest research result. This is the flexible mold machine, and it solves a big problem in the fabrication of freeform facade panels, where we will usually start with a block of material, a CNC machine half of it away. This takes a lot of time, it's wasteful, it's a waste of energy and resources. And we replace this whole process by shaping a flexible silicon membrane into the desired target shape to make your panel.
Cool.
And the way we do this is by creating a frame of MDF or plywood, and we only have to cut these simple 2D cuts in MDF, and we shut our machine, close this silicon membrane, turn on the vacuum, and here you can see the shape forming, and now the silicon membrane here inside has the correct target shape to produce a panel. We can produce these panels by 3D printing or by any manual casting process. And here you can see the simulated 3D printing process. We are currently not extruding any material because this would be a too dirty, messy process here at the Future Facade. Here you can see this frame only, and this would be one of the panels that, for example, we want to fabricate. And now the problem that we actually solved is, if you think of this panel being somewhere here inside, and we stretch the membrane, what exact shape do these support curves have to be so that the membrane takes the correct shape? And this is a difficult problem because you have this elastic, flexible membrane and it's hard to control. But if you have the right simulation optimization tools, we can find the correct shape for these boundaries so that the membrane shape then matches your desired panel.
And how long has this prototype been worked on?
Yeah,
how many years in the making?
Research project, I think we almost worked for almost 2 years. And it took an interdisciplinary team of experts from geometry and computer science and architecture to realize this project.
Yeah. And you can obviously scale this process up, we believe?
Yes, exactly. So we can scale this process up. And if you look at the math and physics, there's nothing that prevents it from scaling even by a factor of 10. And then instead of having these tiny panels, we could make full-size, 4-meter large facade panels.
We have the question of how and where can it be used in sustainable facade design?
So one motivation for this whole project is actually sustainability. The freeform facade is not necessarily sustainable on its own, but we can help to make it more sustainable by making the production of the panels more sustainable. Now, this does not change the sustainability of the design or of the panel itself, but the production of the panels can be made much more sustainable by using this, because we can avoid using the large block of styrofoam, for example, that would usually be required to make a panel. And this block is then afterwards just discarded. And this can easily be 200 kilos of CO2 per facade panel,
Of course.
which we can save.
So reducing the amount of material in the production.
Yes. Yes.
Cool. That makes sense. That's great.